We will see how to find the equivalent resistance when a bunch of resistors are connected either in series or in parallel combination. So today we will find the equivalent resistance when n number of resistors are connected in series. Likewise, we will find the equivalent resistance when n number of resistors are connected in parallel combination. So let's start with the resistors which are connected in series combination. So here we have three resistors R1, R2 and R3 which are connected in series with one voltage source, and the current flowing through this circuit is I. So whenever the resistors are connected in series combination, the same current will flow through each resistor. So here the same current I will flow through this resistor R1, R2 and R3. And because of the flow of this current, there will be a drop across these resistors. So let's say the drop is V1, V2 and V3. So now here we can apply Kirchhoff's voltage law. So applying KVL, we can write Vs minus V1 minus V2 minus V3 is equal to 0. Now using the Ohm's law, we can write this V1 as I into R1, V2 as I into R2 and V3 as I into R3. So we can write Vs is equal to I into R1 plus R2 plus R3. Let us say this is the equation number 1. Now if we replace these three resistors by their equivalent resistance, then the circuit will have a one voltage source Vs which is connected with a equivalent resistance. Let's say that is a R equivalent, and the current that is flowing through the circuit I will remain the same. So we can write Vs as I into R equivalent. And let us say this is the equation number 2. Now comparing equation 1 and 2, we can write I into R equivalent is equal to I into R1 plus R2 plus R3. That means R equivalent is equal to R1 plus R2 plus R3. So we can say that if three resistors are connected in series, then their equivalent resistance can be given as sum of all the resistors. So in general terms, we can say that if n number of resistors are connected in series, then their equivalent resistance can be given as summation of all the n resistors. Now let's see the resistors which are connected in a parallel combination. So here three resistors R1, R2 and R3 are connected in a parallel with one voltage source. Now whenever the resistors are connected in parallel combination, the voltage across each resistor remains the same. So here the voltage across these resistors R1, R2 and R3 will be the same, that is a voltage Vs. Let's assume that the current supplied by this voltage source is I. So this current I will get divided in a three branches, that is a I1, I2 and I3, where I1, I2 and I3 are the currents which are flowing through the resistors R1, R2 and R3. So now here we can apply a Kirchhoff's current law. So applying KCL, we can write I is equal to I1 plus I2 plus I3. Now using the Ohm's law, we can write I1 as Vs over R1, I2 as Vs over R2 and I3 as Vs over R3. So we can write I is equal to Vs into 1 over R1 plus 1 over R2 plus 1 over R3. Let us say this is the equation number 3. Now if we replace these three resistors which are connected in parallel by their equivalent resistance, then the circuit will have a one voltage source Vs which is connected with a equivalent resistance. Let's say that is a R equivalent, and the current that is supplied by the source I will remain the same. So for this circuit we can write I is equal to Vs over R equivalent. Let us say this is the equation number 4. So comparing these two equations, we can write Vs over R equivalent is equal to Vs into 1 over R1 plus 1 over R2 plus 1 over R3. So we can write 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So in this way, if three resistors are connected in parallel, then their equivalent resistance can be given by this expression. So in general way, we can say that if n number of resistors are connected in parallel, then their equivalent resistance can be given by this expression. So now let's take one example based on the series and parallel combination of the resistors. So here we had given one circuit, and in this circuit we need to find the current I that is supplied by this voltage source. So in this circuit we are not bothered about the voltage or current across any of the resistors. So simply we can replace all the resistors by their equivalent resistance, and using the Ohm's law we can find this current I. So if you see the circuit here, these two 5 ohm resistors are connected in a series combination. So we can replace these two resistors by their equivalent series resistance. So let's say their equivalent resistance is Rs, and Rs can be given as 5 plus 5, that is a 10 ohm. So now the circuit will look like this. So now in this equivalent circuit, if you see, these two 10 ohm resistors are connected in parallel. So we can replace these two resistors by their equivalent parallel resistance. So let's say their equivalent parallel resistance is Rp, and Rp can be given by this formula. So we can write 1 over Rp is equal to 1 by 10 plus 1 by 10. That means 1 by Rp is equal to 2 divided by 10. That is nothing but Rp is equal to 5 ohm. So now the circuit will have a two 5 ohm resistors which are connected in a series. Let's say their equivalent series resistance is Rs dash, which is nothing but summation of these two resistors, that is a 10 ohm. So now the circuit has a 1 5 volt voltage source which is connected with a 10 ohm equivalent resistance, and the current I can be given as I is equal to V divided by R, that is nothing but 5 divided by 10. That means I is equal to 0.5 ampere. So I hope you understood how to find the equivalent resistance when a bunch of resistors are connected either in series or in parallel combination. We will see more such examples based on series and parallel combination in the upcoming videos.